Greetings, math fans. All right, so this is our second day of vector applications. And again, these are just more of the same type of problems that you will see on a quiz, on a test, homework. Now, basically, if I can kind of break up the three different kinds of problems, one is going to be you got two different forces. Okay, first force and the second force pulling on the same object. The second kind is pushing something up a hill. And the third are airplane problems, where you have wind hitting the airplanes, okay? So 4 problems to go over today, so let us get started. All right, so a 200-pound force makes an angle of 55 degrees with the second force. So as soon as I see, oh, it's a first force and a second force problem, I'm gonna draw a parallelogram. You just do it automatically, okay? So, let me clear this out here. Okay. All right, so here we go. Okay, so draw a parallelogram. Not the best parallelogram in the world, but it's okay. And I'm gonna draw my resultant force in here too, just to make it pretty obvious. All right, so let's kind of label some stuff. So it's a 200-pound force, makes an angle of 55 degrees with the second force. So that's 55 degrees. Okay, so I'm gonna actually label it just so because I see first force and I see second force. So I'm going to say this is my first force here, and this is second force. Okay, just makes it easier. All right, the resultant of the two forces, so the resultant is the red line, makes an angle of 15 degrees with the second force. So I'm going to do this in a different color. So this is 15 degrees. Okay, find the magnitudes of the second force and the resultant. So I have enough information to basically, I'm going to create a triangle here. That's what I want to do. So if you think about it, this 200 also is here because opposite sides of the parallelogram are congruent. Okay, we already have, that's 15 degrees, but do you guys agree that, we'll make this in blue. Do you guys agree that this angle right here, because remember, if this angle right here was 55 degrees, consecutive angles of a parallelogram are supplementary. So this is 180 minus 55 degrees. Which is 125 degrees. Okay, so that angle is 125. And then we can figure out this angle right here, because it's just a triangle now. You have this angle is 15 degrees here, and this one is 125. So if I add those up, I get 140. So this is 180 minus 140. So that one's a 40-degree angle. And that's enough information now that I can draw a nice little friendly triangle here. I'm just gonna draw that top part, because that's all I need. And this is 15 degrees, this is 125 degrees, and this is 40 degrees, and this was 200. There we go. Now we pretty much have everything that we need, so I'll call this top part here X and Y. So X, of course, is our second force, so let's find that first. Again, I'm going to use law of sines because I have an opposite side angle relationship, so I can do that. So I get 200 over sine of 15 degrees is equal to X over sine of 40. Okay, and then you just cross multiply. You guys can do all that work, but my answer comes out to be 496.7 pounds, right? Don't forget your units. So that is our second force. So let's keep it straight, right? And then Y, of course, is our resultant. So we're going to do the same thing. First proportion is the same. So 200 over sine of 15 degrees. And that's equal to Y over sine of 125. Okay, and again, cross multiply. So Y comes out to be 633.0 pounds. Okay, and that is the resultant. Sweet. Okay, easy problem, really easy, but make sure you draw a parallelogram and keep things straight, okay? All right, moving down here. All right, so V and Rico are pushing a 5,000-pound truck up a hill. Hi, they're strong. With a 6-degree slope. How much force is required to move the truck? So let's go ahead and draw our nice little picture here. Okay, this is the slope, and here's the truck. And it's 5,000 pounds, so this weight is going down. That's 5,000 pounds. And let me draw this in red, but this is V and Rico. They're pushing on the truck. Oh, and let's see, let me label this. This is 6 degrees. Okay? So just remember, just make sure you draw it correctly. Let me finish up the triangle here. That red, well, let's see, I can extend this red. So this red is going to be this red right here. Those are the same lines. And let's just complete our triangle here. It's a little off there, but that's our right angle here. Okay? So if you guys remember, I already explained it, but this 6 degrees here is 6 degrees right here. Okay? I explained it already, and I just want to get through the video now. I explained how that came. If you want to see it again, just watch the day before his video. But that 6 degrees is that 6 degrees on top there, and I'm looking for X. It's easy. I mean, you could use law of sines if you want, or just use right triangle trig. So basically, if I just use right triangle trig, it's sine of 6 degrees equals opposite over hypotenuse. So I cross multiply and solve. I get X equals 522.6 pounds. So they have to push that hard on the 5,000 pound truck, which kind of makes sense. 6 degrees, it's not too big of a slope, right, to push up there. So it's a 5,000 pound truck, so you got to push a little bit. Got to, you know, they're tough kids. You can probably push that weight up there. Okay. All right, so that's pretty easy. Okay, so we're going to definitely see each one of these on a quiz, test, final exam. You'll see them, I guaranteed. Or I guarantee. Okay. So number 3, Captain Caleb flies his plane 500 miles an hour on a bearing. Boop, boop, boop. Soon as you see the word bearing, you have to draw a bearing line. I make a big deal out of it because back in the day when I first started teaching this, I would say, oh, bearing, and people would just move on to the problem. Okay? You have to draw a vertical line. Please do not draw a horizontal line. That's like really bad. So you need to draw a nice little vertical line here. And it's 215 degrees. So, here's 215 degrees. There's the plane. Okay, and I drew it a little more extreme. Oh, that's weird, it just went away. So what I don't want to happen is, let's draw that back in there. Okay. Let's say it's, I said 181 degrees. I don't want you guys to draw 181 degrees and barely see the angle. Draw a little more extreme, so you at least see the angle. You see this on the bottom here, there's kind of a nice, you see a big angle, like maybe 30 degrees, whatever. Just draw a little more extreme so you kind of see what's going on, all right? Okay, so, and this is 500 miles an hour. So then a 30 mile an hour wind from a direction. Now guys, you have to know to do this. You have to draw another dotted line here, okay? That's really important. Okay, and it's got to be at the tip of the plane, okay? Basically at the arrow, because the wind is hitting the front of the plane. If you draw that dotted line anywhere else, you're going to get the problem wrong, okay? So understand, you're drawing 2 lines all the time. The first dotted line is the actual airplane, for the airplane, and the second one is for the wind. And the wind hits the airplane at the tip of the plane, at the arrow. Super important. Okay. So let's move on to this word right here, from. A 30 mile an hour wind from a direction of 270. Please understand what from means. From means, well, look, first of all, let me draw 270. So I'm just going to draw the line. This is 270 degrees. And it's a 30 mile an hour wind. Okay? Which way is it going? It's from 270. Can everybody please look to your left? Okay, look to the left, and if I'm coming from that direction, which way am I going? I'm going to the right. Okay? Think of it this way. If you're coming from Grandma's house, and Grandma lives to the left, and you're coming from Grandma's house, that means you're going to the right. Okay, you're not going to Grandma's house, you're coming from Grandma's house. So you look at Grandma's house, and you go the other way. You're coming towards you. Okay? So this arrow is going to point this way. All right, so, and you can't draw the picture this way because it's basically tip to tip. That's wrong. It's going to be tip to tail. So I'm going to actually extend it out this way. This is what my arrow really looks like. Okay, and this is the resultant of the airplane. So that makes sense. If the wind is pushing it, coming from the left and pushing it to the right, isn't it changing that 500 mile an hour plane and making it go more to the right? Okay, that is super important. You guys get this. This is really, really important. All right, so once you have this picture, my goal, math fans, is always to find, and by the way, I'm going to label this is also 30. So now we have this 500 and this 30. I want to find the angle between the two vectors. This is my goal. I need to find this angle right here. The angle between the two vectors, between the 500 and the 30, because I need to be able to use law of cosines to figure out that right arrow. Okay, the right arrow or the red arrow. Okay, so as I taught you guys already, you're going to use both pieces of information in this calculation. So the first thing I'm going to do is, if that's 215 degrees to that 500, do you guys agree that this right here is 215 minus 180? That gives me 35 degrees. Okay, that is going to give me this 35 degrees. Usually we're doing almost the same thing every time. So that's alternate interior because those two dotted lines are parallel. So that's 35 degrees. So that's kind of nice, because what is this whole angle right here? Because this is 270, I'll use red here. Do you guys agree that this, because that's 270, this is the right angle here? Okay, and if I subtract that angle, so let me do it in a different color here. Let's do it in gray, even though gray doesn't really show up that well. That gray is going to be 90 minus 35, which is 55 degrees. And that's what I want. That is 55 degrees. Super, super, super important. So now if I draw this triangle again, this is 55 degrees, this is 500 miles an hour, and this is 30 miles an hour, and I'm looking for x. It's the law of cosines, guys. Okay? So x squared is equal to 500 squared plus 30 squared minus 2 times 500 times 30 times cosine of 55 degrees. Don't forget to take the square root, and x is 483.4 miles per hour. Okay, there you go. Pretty sweet. Now I need to figure out how the resulting course. That was my ground speed. I need to figure out the course. Well, I'm always looking for this theta right here because I want to see how much that wind is pushing it off course. So I'm kind of running a little bit out of room here, but I'm basically, I'll do it right here in the corner here. So I'm going to use law of sines. Now that I know this x, that's 483.4. Of course, not using a rounded value, it's been your calculator, over sine of 55 degrees is equal to 30 over sine of theta. Okay, you cross multiply, take inverse sine, so theta equals 2.9 degrees. Now, if you put 2.9 degrees as an answer, boo! Okay, that's not a good answer. That doesn't make sense, 2.9 degrees. That's how much is blowing off course. So do you subtract 2.9 from 215? Because 215 is the original course of the plane. But no, do I add or subtract? So which one do I do? Well, isn't it going less? Isn't this, here, I'm going to use solid, I'm going to use blue here. Do you guys agree this is the original course of the plane? And if I'm going this way, isn't it 215? I'm going less. 215, 214, 213, 212, 211. I'm going less. So actually, it is going to be 215 minus 2.9 degrees. So that's going to give me 212.1 degrees. And that is my new bearing. Okay? So those are the two answers. Okay? That's how you do that problem. So they're all the same, guys. They're all pretty much the same. Alternate interior angles. You just have to look for, and some of you guys might say, well, Mr. Curve, I kind of did it a little bit different way. As long as you used correct geometry, you are good to go. If you don't use correct geometry, you're not good to go. Okay? All right. So let's do one more here. Okay, Asta. Oh, she's flying the acrobat. Asta the acrobat flies her plane 500 miles an hour on a bearing. Boop, boop, boop. Again, super important. So here we go. On a bearing 65 degrees. So we're going to go 65 degrees. Okay, and it's 500 miles an hour. A 30-mile-an-hour wind in the direction of 25. So I'm going to draw another dotted line. I don't even know what's going on yet. I'm just going to draw the dotted line because I know the wind is hitting it right here. In the direction of 25. So 25 degrees is actually looks like this. This is 25 degrees. I know it's kind of crunchy here. Sorry. Okay, that's 25 degrees. And it's in the direct. So I drew the arrow that way. I shouldn't draw in the arrow yet because I want to talk about it. In the direction of 25. So see how I drew the arrow? That's 25 degrees. It's going in the direction of it, so I draw it in the direction of it. Just like if I said in the direction of to the right, which way would you go? You would go to the right. So if I said in the direction of 25 degrees, you go to 25. Okay? That's the setup for that. They really are not difficult problems. Okay, so let me sketch the resultant in. This is just a little bit different. Okay, like that. That's the resultant. Okay, let me draw the arrow. Okay, so now what we're going to do is, oh, sorry, I need to label this. So this is 30 miles an hour. All right, so let's do this. See that 65 over there? A couple things I can do. I could do alternate interior, but guys, think logically. I need to figure out the angle between the two vectors. I need to figure out this angle right here. Well, isn't that 25 degrees up there? And what is this angle? Let me do it in green. What is just this part of the angle? Well, can't I use that 65? And aren't those supplementary? Right? They're same side interior. Now, some of you said, well, Mr. Curvis, couldn't I have done 65 and I could have done 65 down here and then subtract from 180? Oh, yeah, okay, you could do that too. That's fine. Or just know that this angle is 180 minus 65, which is 115 degrees. So if the green's 115, that means the blue is going to be 115 plus 25, which is 140 degrees. And there we go. Okay, so let's, and that's all I need. So I'm going to actually resketch this picture now. I want to save a little room so I can actually, I know it's not a good picture. It's okay. So this is 140 degrees. This is 500, and this is 30. So let's use law of cosines. X squared equals 500 squared plus 30 squared minus 2 times 500 times 30 cosine of 140. Okay, so X comes out to be 523.3 miles per hour. Okay, cool. That's the ground speed. The course, again, look at what's going on here. Is that wind making it less or more of an angle? Well, see how it's 65 degrees? Isn't the wind pushing it more to the left? Look at that red line that I drew here. Isn't it less of an angle as opposed to this line right here is 65 degrees? Isn't the red line is right here. That's less of an angle, so it means I'm going to subtract the angle once I get it. So I need to figure out this theta right here to see how far the plane is blowing off course. Don't do anything goofy and look at what the wind is not going off course, it's the plane. So anyway, we get 523.3, which is stored in your calculator, over sine of 140 is equal to 30, which is the opposite side, over sine of theta. So again, cross multiplying, theta comes out to be 2.1 degrees. Okay, and then we said we're subtracting, it's less of an angle. So our resultant course is going to be 65 degrees minus 2.1, which is 62.9 degrees. And that is our new bearing. Boop, boop, boop. Okay? So that's it, math fans. These are all the bearing problems that you can have. You got to practice them. So all the homework problems, all the solutions are in the Google Drive to check to make sure you know what you're doing. But make sure you know what you're doing and draw good pictures. That's the key. Okay? The key. It's a key to doing these problems well is, like I said, just drawing a good picture. All right, that's it, math fans. You have an outstanding day. Adios. Goodbye.